Hello, everybody, and welcome back to another episode of this series. We are trying to write a kernel from scratch. So, the last few episodes, we are working on a body allocator to use for our general purpose heap allocator. Look at me being unprepared. Let me zoom this in a bit. Last time, I think if I go to here and I do I think test, we had a slight issue where one of our pointers just got overwritten with undefined, and we did not know why that is. Actually, more than just one pointer, because this length here is also changed. So today we are going to try to debug the test and see if we can find why this is happening. Let's get to it. All right, so I want to add a new test debug step. So just taking a look at what we have here, I think I can do this, bring that here and have that as a standalone. And I could also just put those together. And here I can go ahead and do debug or run LDB. And that would be add system command. This takes a slice of slice. So that's that. This would be LDB, and this would just forward the arguments. And then I'm going to have debug step, which would be b.step. I'll call it debug. And as description, this would be debug tests. Yeah, sure. And then, of course, I'm going to have to do that debug step. Step has to depend on run ldb.step. I think this needs to be a reference. And of course here run ldb needs to have the test binary that gets built. We did not give it a name. We did not install it, so it should be in the zig out folder. But I'll use add artifact arg so that the name or the path to that binary gets fed automatically to LDB. So this artifact here would need to be tests, I think. Yeah, that should do the trick. So here I should do, so if I go ahead and do zig build debug, I should have LDB run. Cool. And if I do run, I should have my test go. Very nice. So with this, I could go here, go to my test, which is somewhere here. Yeah, so the problem happens right about here. So if I go ahead and do a breakpoint and rerun zig build debug. Okay, so here we are. So here if I try to, first of all, let's get locals. Okay, well, it's not the same as GDB. So let's take a look at the documentation. So I need to do frame variable or FRV. Okay, nice. So we do have our buffer. It's full of undefined. And then we have our body, which has a pointer, a vtable. That's all fine. And then we have our allocator. That's okay. And then we have our slice, and that's pretty okay. So now what we need to check, or what we need to do, is make sure that body.memory start, so this variable here, as well as memory length, does not get overwritten, or if it does, I want to set a breakpoint. Let's look for right. Okay, that's not really what I'm looking for. Okay, set a watch point. Okay, so watch and the global variable. Okay. So let's do that. So that will be watch, and this would be body.memory start. Should I add variable in the watch point? What was it then? Watch. Oh, so this one here. Set variable global var. Watch set variable body.memory start. Okay. So that's the current value we have, isn't it? 5 zeros. Okay, it's fine. So let's step. And here in memset.zeg, so if I backtrace this, so what is happening here? Alloc with size and alignment, alloc with alignment, and then here we have memset. So it's in allocator. So let's go there. So it should be over here. It should be line 273. Okay, so it's as I thought. It was this memset here that overwritten our variable with undefined. Right, now the question is, why does it do that? Because what it should do is overwrite the data pointed to by the value of our memory or our pointer. But yeah, not sure. So let's try to go to frame 1. How do you switch frame? Frame. Oh, so it's BT5. BT1. Wait, what? Oh, so it's frame select and so frame select 1. Cool. Right, so now what I want to do is just print byte pointer. Okay, so byte pointer does point to our memory here. So it looks okay because byte pointer is whatever this buffer here points to. Yeah. Did we print buffer? Yeah. So buffer is this D7A8. D7A8. Yeah. So byte pointer has the correct value. Now, so why are we huh. Yeah, so why are we having this be overwritten though? So line 19 of memset, we set this value here, which would be just undefined to d of 0. But yeah, I'm not sure. So frame select 0 and let's print d. Print d. How do you print in this thing? Print. So just p. Cannot get the value of variable. The variable is not available. Okay, fine. That's okay. So let's do so it's register read. So RAX should be the value that we set to, and it does look like the correct value. Now the other question would be, what is the address of body in all this, and why does it get overwritten? And for that, I think I'm gonna stop this. Yes, quit it for now. I'm gonna go back to here, and I'm just gonna add this body, and we just going to take the address of body, just so that we know where it sits in memory. And let's go back. And of course, we are going to need to do, actually, never mind. We can just do something like this. All right, so let's run this. Can we do, so what was it, watch point read? How watch point? Watch point. How do we list them? List. Okay, fine. So watch point list. So no watch point set. Cool. Right. So where is our body in memory? It's at this address here, 7D0. No. What is going on? Why is our body getting allocated at the exact same place where we have our buffer? So let's do this again. So let's go back to here. We get back a body that's been created here. It's gonna get copied over. It has the memory start and the allocator in it, and we have the single item that we have allocated from our allocator here, which is our first node, which happens to be in the highest order bucket. So why does this sit at the exact same address as our buffer? And this explains why we are getting overwritten, because we try to memset our buffer and our body. Oh, well, never mind. No, it's not the exact same. Yeah, what am I saying? Yeah, no, that's not it. That is not it at all. Our body is over here and our buffer is here. Yeah. So let's also do print alloc. So alloc has pointer is our body, which is okay, and vtable is whatever, we don't care. And if we print body, we should see that well, first of all, memory start does not look good. Let's print. I hope that works. Body.memory start. Okay. So is that the correct value? 7A0. Oh yeah, okay, that's fine. That looks like our correct value. And yeah, it all looks good for now. Okay, and we want to go ahead and add a watch point set variable body.memory start. Right, so we hit step and we are in allocator whatever. So let's hit step again. Now we are going to go through all of those functions. So here we are going to actually call to get the allocation. So let's do that. Alloc with size and alignment. Yeah, sure, fine. Let's do this. We do the test. That's all good. So all of that is fine. And here we should just call into alloc bytes with alignment. It's okay. Here we are going to just skip this because it's not what we are going to. Oh, wait, what? If bytes count is 0, we... Huh. So print byte count is 80. So why do we go into there? Okay, so it was just a printing error. Okay, so here we are going to call raw alloc, and that should basically bring us. It should go through our allocation logic, and if we just print byte pointer, that should be, yeah, as we expected. This is the first address of our buffer. So we have allocated our first memory. And if we go, I'm not sure if it's still in scope, but if we, yeah, of course it's not in scope. But now, if we try to, let's also print byte count just to make sure. Is that like, so what are we asking for? We are asking for the new 64s, so that's 80 bytes. Yeah, okay, that's correct. And that means that if we try to print, let's call it car star, was there something for arrays? Print p array 10 pointer. Yeah, sure. Okay, so p array 80 byte pointer. Okay. So what is going on here? Shouldn't this just be hold on. I am surely missing something. So let's go back here. Okay, let me do this again. I'm just gonna quit. I'm gonna stop this, and I am just going to get rid of all the printing. Print. Right, so this one goes, these two go, these two go, this one goes, I think that's pretty much all the ones I want to get rid of. So let me do this again. And actually, let me add one more. Oh, wow. Very nice. Very cool. Okay. Wow. Okay, I see the problem. It just dawns on me now that I might or might not be a bit of a ding dong when it comes to this. Right. So if we just do this again, let's rebuild it, and if we run it, we should. Let me just set watch point again. Set variable body dot memory start. Okay, so let's go. And we haven't overwritten it this time. So I guess if we do things correctly, there are no problems. Okay, fine. So let's run this one more time. What's the problem here? Buffer, whatever. Oh, yeah, fine. So it's the breakpoint. Didn't like that. And it does work. Wow. Would you look at that? All right, let's do this, and let's run this again. Right. So buffer was, what was the expectation that got Oh, of course. Well, this will teach me to do that. Very nice. Very nice. Cool. Well, that's pretty much our problem solved. I just need to be a bit less of a R word. I think I have proven once again that the secret to writing working code, I guess that's the quantifiable measure, is to try to be less of a moron than I usually am. I guess that's the takeaway from this video. Well, on that note, if you've liked this video, hit like and subscribe. If you have a question or a remark, leave a comment. And as always, I'll see ya. Fucking out.